From the dawn of the atomic age to the chilling standoffs of the Cold War, the specter of nuclear weapons has haunted humanity, representing the apex of our destructive capability. But not all of these apocalyptic devices are created equal. While often used interchangeably, the terms nuclear bomb and hydrogen bomb describe two distinct tiers of destructive power, rooted in different principles of physics. One splits the atom, the other fuses them together. So, what truly separates the bomb that leveled Hiroshima from the far more powerful thermonuclear weapons that followed? Let's delve into the core of the atom to uncover the difference. The story begins with fission, the process that powers what we commonly call an atomic or nuclear bomb. At its heart, a fission bomb is a device designed to trigger a runaway chain reaction. It uses a core of heavy, unstable elements like uranium-235 or plutonium-239. When a neutron strikes the nucleus of one of these atoms, it causes the nucleus to split into smaller fragments, a process known as nuclear fission. This split releases an immense amount of energy, along with 2 or 3 additional neutrons. These new neutrons then fly off to strike other nearby nuclei, causing them to split as well. This creates an exponentially growing chain reaction that releases a cataclysmic amount of energy in a fraction of a second, resulting in the characteristic mushroom cloud and devastating blast. The bombs dropped on Hiroshima and Nagasaki were fission bombs, and their destructive power, measured in kilotons of TNT, forever changed the landscape of warfare and global politics. However, fission was only the first step. Scientists soon realized that an even more powerful reaction was possible: nuclear fusion. This is the very same process that powers our sun and stars. Instead of splitting heavy atoms, fusion involves forcing the nuclei of light elements, typically isotopes of hydrogen called deuterium and tritium, to merge together under extreme pressure and temperature. When they fuse, they form a heavier nucleus, like helium, and in the process, release a quantity of energy that is many times greater than that of a fission reaction. This is the principle behind the hydrogen bomb, also known as a thermonuclear weapon. The catch, however, is that achieving the millions of degrees Celsius required to initiate fusion is incredibly difficult. The solution was to use a fission bomb as a trigger. A hydrogen bomb is a multi-stage device. The detonation of a primary fission bomb creates the intense heat and pressure needed to ignite the secondary fusion fuel, unleashing a far more powerful explosion. The key differences between these two types of weapons lie in their mechanism and their destructive yield. Fission bombs are limited in their potential power by the amount of fissile material you can safely pack together before it becomes critical. Their power is measured in kilotons. Fusion bombs, on the other hand, have a much higher theoretical ceiling. Because the fusion fuel is only ignited by the primary fission explosion, you can add significantly more of it to increase the weapon's yield. Consequently, the power of hydrogen bombs is measured in megatons or millions of tons of TNT. The largest bomb ever detonated, the Soviet Union's Tsar Bomba, was a 50-megaton thermonuclear device, roughly 3,300 times more powerful than the bomb that destroyed Hiroshima. This staggering leap in scale represents the fundamental distinction between the two. In the end, while both are terrifying instruments of destruction, the difference between a fission bomb and a hydrogen bomb is a matter of fundamental physics and exponential scale. The first splits the atom to release its energy, while the second uses that initial blast to ignite an even more powerful stellar fire, fusing atoms together. Fission was the first terrifying chapter in the atomic story, but fusion represented a quantum leap into a new and even more perilous era of destructive potential. Understanding this distinction is crucial to grasping the true scope of the nuclear threat and the profound responsibility that comes with wielding the power of the stars.